Hello guys, welcome to my channel Science to Scientist. I am Ritik Singh and today we are going to sum up all we have studied about atom. So let us begin our today's video. Atom was discovered by Dalton and it is the smallest particle that takes part in chemical reactions. It contains three fundamental particles, namely electrons, protons and neutrons. Talking about subatomic particles, a large number of subatomic particles have been discovered till now. But on an electron, proton and neutron are of great importance among them and hence are called fundamental particles. Now various experiments that led to discovery of fundamental particles are as follows, that is cathode rays and anode rays. Cathode rays were discovered by Sir J.J. Thomson. And cathode rays were a stream of fast-moving negatively charged particles called electrons. The specific charge is the ratio of charge to mass of an electron. It is founded by Thomson and denoted as E by M ratio. The E by M ratio of electron was found to be same for all gases. The value of E by M ratio is 1.758 into 10 to the power 11 coulomb per kg. Anode rays, also called as positive rays or canal rays, were discovered by E. Goldstein. These rays consist of positively charged particles called protons. Unlike cathode rays, their E by M value depends upon the nature of gas taken in the tube. The E by M value is maximum when hydrogen gas is taken in tube. Talking about neutrons, neutrons were neutral particles and discovered by James Chadwick. Neutrons are the heaviest particle in the atom.
Here we will see the characteristics of the fundamental particles. It's very important. So particles is electron, protons and neutrons. We will be seeing its mass, its charge, its unit, its symbol, discoverer and the presence of the fundamental particle. First we will be seeing of electron. In CGS units it's 9.1 into 10 to the power minus 28. In CGS unit it is measured in grams. In SI unit it is measured in kg, that is 9.1 into 10 to the power minus 31. In EMU, that is astronomical unit, it's 0.00055, which is equivalent to 0.00. The charge in ESU is minus 4.8 into 10 to the power minus 10. Whereas in SI, that is in coulombs, is minus 1.602 into 10 to the power minus 19. The unit is minus 1. Symbol is minus 1 raised to the power E raised to the power 0. The discoverer was J.J. Thomson and the presence is outside the nucleus. Now proton in CGS units is 1.6 into 10 to the power minus 24. In SI it's 1.6 into 10 to the power minus 27. In AMU it's 1.00728, which is equivalent to 1.00. The charge in ESU is plus 4.8 into 10 to the power minus 10. In SI unit it's plus 1.6 into 10 to the power minus 19. Unit charge is plus 1. Symbol is plus 1 P raised to the power 1 or plus 1 H raised to the power 1. The discoverer is Goldstein and it is present inside the nucleus. Second is neutron. In CGS it's 1.6 into 10 to the power minus 24. In SI it's 1.6 into 10 to the power minus 27. In EMU it's 1.00867, which is equivalent to 1.0. The charge in ESU is 0, SI 0, unit is 0 and symbol is 0 n raised to the power 1. It was discovered by Chadwick and its presence is inside the nucleus.
Talking about atomic models. To describe the atomic structure, following atomic models were given below. That is Rutherford model of an atom and Bose model of an atom. Rutherford's model of an atom. On the basis of alpha particle scattering experiment, the nucleus was discovered by Rutherford. Rutherford's model of an atom or structure of atom can be described as follows. That is, first, an atom consists of a positively charged, dense and very small nucleus containing all the protons and neutrons. Almost the entire mass of atom is concentrated in the nucleus. Second, the nucleus is surrounded by a negatively charged electron. The electrons are revolving around the nucleus in circular path called orbits. Third is, atom is electrically neutral due to same number of protons and electrons in an atom. Fourth, most of atom is empty space. Now, what were the limitations of Rutherford's model? A major drawback of this model of the atom is that it doesn't explain the stability of the atom. Actually, according to electromagnetic theory, if a charged particle moves around positively charged nucleus, then it will lose energy continuously and finally drop into the nucleus. Now, Bohr's atomic model. Bohr's model is applicable only for electron systems like hydrogen, helium plus or lithium 2 plus, etc. So its main postulates are electron revolves around the nucleus only in stationary part called energy levels, orbits or shells. Which energy level has a definite energy associated with it. As one moves away from the nucleus, the energy of the states increases. Angular momentum of an electron is an integral multiple of h by pi, that is, mvr equals nh by 2 pi, where m equals to the mass of electron, v velocity of electron, r radius of orbit and n numbers of orbits. Energy is emitted observed on U when an electron jumps from higher energy level to lower energy level and vice versa. From Bohr's model, energy velocity and radius of an electron in nth orbit are calculated as first, velocity of an electron in nth Bohr orbit and second by radius of nth Bohr orbit. So first discuss about velocity of an electron in nth orbit. That is Vn equals 2 pi e square by z into z by nh, which is equal to V0 into z by n, where V0 is 2188, that is 2188 into 10 to the power 8 centimeter second inverse, whereas radius of nth Bohr orbit is Rn equals n square h square by 4 pi square me square by z, which is equal to R0 n square by z, where R0 equals 52.9 pm. The above relation suggests that with an increase of energy level n, the radius of atom also increases. Thus, R1 by R2 is equal to n1 square by n2 square. In this, when we plot a graph between R and n square, keeping n square at base and R in perpendicular, we get a equivalent graph at 45 inclined at 45 degrees, and it n is constant, that is R1 by R2 equal to Z2 by Z1. That is, the graph will be plotted between R and 1 by Z. So in this also the graph will be inclined with the base of 45 degrees. Now third is energy of an electron in nth orbit, that is En equals minus 2 pi square mz square by into e raised to the power 4 by n square h square, where En equals minus 2178 into 10 to the power minus 19 z square by n square, that is joule per atom. So del equals minus 2.178 into 10 to the power minus 18 into 1 by n1 square minus 1 by n2 square into z square in joule per atom, where n is number of shell, z is atomic number. So the limitations of Bohr model. Bohr left following facts on unexplained, that is fine structure of atom, spectrum of multi-electron system, Zeeman effect and Stark effect, that is splitting of spectral lines under the influence of magnetic and electric field respectively. And the last is the three-dimensional existence of atom. Now talking some extra facts about dual nature of electron. The number of spectral lines in the spectrum when the electron comes from in level to the ground level will be n into n minus 1 by 2. The intensity of spectral lines decreases with increase in the value of n. Example of this is the intensity of first Lyman series, that is 2 tends to 1, is greater than second line, that is 3 tends to 1, and so on. Moving further to electronic configuration of elements, The arrangement of electrons in different shells of an atom is known as electronic configuration of the element. Following rules are used to write the electronic configuration, that is Bohr-Bury scheme. Electronic configuration of an element can be written by Bohr-Bury scheme in such ways. Maximum of number of electrons which can be accommodated in any orbit is given by 2n squared. Second, in stable atom, outermost orbit can have maximum 8 electrons. Similarly, for 10 ultimate orbit, they should be maximum 18 electrons. Exception having first orbit. In the outermost and penalty main topics, there cannot enter more than 2 and 8 electrons respectively, and less inner orbitals cannot fulfill. Moving to Aufbau's principle, according to this principle, subshells are filled with electrons in the increasing order of their energies. That is, subshell of lower energy will be filled first with electrons. The order of increasing energy is summed as 1s, 2s, 2p, 3s, 3p, 5s, 4s, 3d, 4p, 5s, 4d, 5p, 6s, and so on. Note that chromium-24 and copper-29 do not obey this law, as chromium-24 electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 3d5 and 4s1, whereas copper-29 have 1s2, 2s2, 2p6, 3s2, 3p6, 3d10 and 4s1. So both of them do not follow Aufbau's principle. Moving further to Hund's rule for maximum multiplicity. That is, according to this rule, pairing of electrons in a subshell starts after all the available atomic orbitals are the subshell are singular filled, that is half filled. Pauli exclusion principle. It states that no two electrons can have the same value of the 4 quantum numbers. Note, exactly half filled subshells have less energy, and as you move stability than any other arrangement. Thus, P cube is more stable arrangement than P squared, P4 or P5. Moving to valence electrons, the electrons present in the outermost shell of an atom are known as valence electron because they decide the valency of an atom. Only valence electrons take part in the chemical reaction. Representation of atom. An atom is generally represented as following symbol, that is Za. In the symbols that represent the atomic number, Z, which is generally equal to the number of protons, A represent mass number, it is the sum of number of protons and number of neutrons in nucleus. That is, mass number equals number of protons plus number of neutrons. In case of neutral atom, number of protons and number of electrons are equal. Discussing about different types of atomic species. On the basis of number of electrons, protons and neutrons present, there are following types of species. Isotopes. Species with same atomic number but different mass number are called isotopes. Example is 1H1 or 1H2. Isobars. Species with same mass number but different atomic number are called isobars. Example is 18Ar40 or 19K40. Isotones. Species having same number of neutrons are called isotones. Example is 1H3 or 2He4. Now isodiphers. Species with same isotopic number are called isodiphers. Example is 19K39 or 9F19. Isotopic number is equal to mass number minus 2 into atomic number. Isoelectronic. Species having same number of electrons are called isoelectronic species. Example is N2O or CO2. Isosters. Species having same number of atom and same number of electrons are called isosters. Example is N2 and CO. Radioactivity may be defined as spontaneous emission of suitable particles and electromagnetic radiations by unstable nuclei. It was discovered by Professor Henri Becquerel in 1896. Radioactive rays. The rays emitted from radioactive substance are called radioactive rays. It is of three types: alpha rays, beta rays and gamma rays. Alpha rays, they are deflected towards negative plate in an electric field. Each particle carries 2 unit positive charge and 4 unit mass. That is, it is doubly ionized helium nucleus. They produce maximum ionization in gases because of maximum kinetic energy. Their penetration power is very small because of large masses. Velocity of these rays is 1/10 the velocity of light. Talking about beta rays, they are deflected towards positive plate in an electric field. Beta particles carry 1 unit negative charge and negligible mass, that is, these rays are made of electrons. They produce lesser ionization in gases than alpha particle. Emission of one beta particle from unstable nucleus results in increase in the number of protons by 1 unit. Talking about gamma rays are electromagnetic radiations of very high frequency, even more than X-rays. Thus, the gamma rays have no charge and no mass. They are not deflected from their path in electric and magnetic field. They produce minimum ionization in gases. They possess maximum penetration power. Moving to nuclear stability, due to very small size of nucleus, there are very large repulsive force between protons. Presence of neutrons in nucleus decreases these forces. Show stability of nucleus depends on the ratio of N and P. That is, N by P for stable nucleus, N by P should be 1.0 minus 1.6. Disintegration constant, the fraction of the total number of atoms which disintegrates per second at any time, is called disintegration constant. Lambda equals 2.303 by T into log to the base power 10 N naught by N, where N naught is the initial amount while N is the amount left after time T. Half-life period of radioactive substance. Half-life period of any radioactive substance, that period in which it remains half of its initial amount. It is represented as T half, that is T 1 by 2 equals 0.693 by lambda. Half-life period of particular radioactive substance is independent of initial amount of radioactive substance. Now, group displacement law. The law was presented by Fazan, Soddy and Russell in 1930. According to this law, when an alpha particle is emitted, the daughter elements has atomic number 2 units less than that of the parent element. It is consequently displaced 2 places, that is groups, to the left in the periodic table. When a beta particle is emitted, the daughter element has an atomic number 1 unit higher than the parent element. It is consequently displaced 1 place, that is group, to the right in the periodic table. From uranium of group 6th group, when hit by alpha particle, it becomes thorium of group 4, and when hit by beta particle, it becomes palladium of group 5. Now, types of nuclear reactions. Nuclear reactions may be occurred in following ways, that is nuclear fission. It is the phenomena of splitting of a heavy nucleus into 2 or more lighter nuclei with the evolution of large amount of energy. Example, uranium when hit by a neutron gave rise to Ba, and krypton plus 3 neutrons plus energy. 2 types of chain reaction occur in nuclear fission. That on controlled chain reaction, atom bomb is based on it. Whereas on controlled chain reaction, these reactions occur in nuclear reactors. In nuclear reactor, uranium-235 or Pu-239 are used as fuels. D2O or graphite is used as moderator. CD or B rods absorb neutrons. These are used as control rods. Liquid sodium is used as coolant. Now, nuclear fusion. It is the phenomenon of using 2 or more lighter nuclei to form a single heavy nucleus with large amount of energy. Example, hydrogen bomb and energy of sun. Uses of radioisotopes. CO60 is used to cure brain tumors and cancer, whereas C14 is used in carbon dating. I-131 is used in treatment of thyroid glands, and N824 is used to measure the speed of blood circulation. By this, we have seen all about atoms. This comprises from study between class 9th to class 12th or higher levels. If you have not understand, we will be doing in frequent chapters or frequent videos to resolve what are the further topics which we have not studied till yet. So stay with me, and if you like this video, please don't forget to like it, subscribe it or share it. If you have any doubts regarding this video or any previous video, just give or comment in the comment box. Thank you.